Today I will teach you Aldol condensation reaction. Let's see the general reaction for aldol condensation. In aldol condensation, these two words are there: aldol and condensation. Aldol means what? It is a aldehyde plus alcohol. Two functional groups are there, and that thing we'll see in our product in between. And then that aldol is further condensed, and that produces our final product, which is alpha beta unsaturated aldehyde. Now we'll see that which reactants we require to perform this reaction. So to perform this reaction, we should have aldehyde or ketone. You can choose whatever, aldehyde or ketone, but in this reaction there is a one condition, and that condition is what? Whatever aldehyde or ketone you are going to choose, they must have they must have alpha hydrogen. They must have alpha hydrogen. And in this reaction, we have taken aldehyde, which is acetaldehyde, and you can see that that particular aldehyde is having alpha hydrogen. The carbon next to functional group is known as alpha carbon, and the hydrogens which are connected to that alpha carbon are known as alpha hydrogen, and this kind of compound we need to perform this reaction. Now 2 moles of aldehyde or ketone be required. The reactant should be 2 moles. If you are choosing acetaldehyde or whatever aldehyde or ketone containing alpha hydrogen, should have 2 moles. That means 2 moles of reactants will choose, and you can see that I have taken acetaldehyde in this reaction, and 2 moles of acetaldehyde are there, and that two aldehydes are going to react with sodium hydroxide and water to produce alpha beta unsaturated aldehyde, or we can say alpha beta unsaturated carbonyl compound that will get. So why alpha hydrogens? The first question to understand that why alpha hydrogen we are choosing in feature of alpha hydrogen, that is acidity. They are acidic. Alpha hydrogens are acidic, and that thing we are going to use as a strategy. That thing, which thing? Alpha hydrogens are acidic. That concept we are going to use as our strategy to produce this kind of compound. What strategy? How? So first of all, we'll see that why alpha hydrogens are acidic in nature. Why they are acidic? This is acetaldehyde. Now when base is going to come, when the base is going to come, for example, strong base hydroxide is there, and that base is going to come and get the proton and will live as a water. What is going to happen? Hydrogen, this proton is going to leave, and we know that. What is acidity? The compound which donates proton, that is acidity. So the H is going to leave from this compound, and when this H is going to leave, this bond between carbon and hydrogen is going to break, and when this bond is going to break, this bond have that electrons which are going with carbon, because of carbon is more electronegative than hydrogen. So when the bond is going to break, the more electronegative atom will retain the electrons, will get that electrons, will have that electrons. And now once H is going to leave, there is a formation of carbon anion, and this particular intermediate is known as enolate, and this enolate can go under resonance. You can see that this carbon anion which have a lone pair, that lone pair can make double bond, and then this pi bonds electrons are going to accommodate on the oxygen, and there is a formation of a resonance, and this resonance is going to stabilize this particular conjugate base. And you know that more the stability of conjugate base, more the stability of conjugate base, the more acidity. When this conjugate base is being more stable, now this conjugate base is not going to get this proton back. You know, once H plus leaves, that is reversible. This electrons can again regain this proton and to form this stable product, this stable compound. But what here is going to happen, because of this resonance, this conjugate base is being more stable, and because of that, now the stability is more, so it is not going to get that proton, and the acidity is going to increase because the concentration of H plus will remain more, and that is what higher acidity are acidic in nature. So this strategy will use to make a strong nucleophile which is enolate in our case, and this enolate we are going to use further to attack on the second aldehyde, the second unreacted aldehyde, and that particular enolate will attack on the electrophilic center of second aldehyde, and simply we are going to connect this carbon with this carbon to have a bigger molecule. And this reaction is a condensation reaction. And what is the definition of condensation? Simply it is, we can say that two small molecules are going to make a bigger molecule, and during that there is a removal of water. This is a simple definition of condensation, and this condensation of aldol, and because of that we call it aldol condensation. And now this strategy help us to make this connection between this carbon and this carbon, because why, because we simply want to merge them, we want to connect this carbon with this carbon. You can see that we want to connect this carbon with this carbon, and for that what we need to do something that can connect them, and for that we are going to abstract one alpha hydrogen via base, and then there is a formation of strong enolate ion, and further that strong enolate ion is going to attack to make connection between them and to get the bigger molecule. If you don't have alpha hydrogen, then you will end up with the Cannizzaro reaction. So you can see that how this is. Now we'll move to the mechanism of this reaction. We have 2 moles of aldehyde that contain alpha hydrogen, and now we have a strong base in our reaction as well. And now the strong base, which is Na plus and OH minus, and this is base and this is nucleophile, and now this is a base, and this is going to get one alpha hydrogen and will form a water, and the water is going to leave. So now there is a formation of enolate ion that we have discussed before. This enolate ion is formed, and now this enolate ion is a strong nucleophile. We can also say that in this mechanism, the first step is to generate the enolate ion, to produce an enolate ion. So in the first step, we have produced enolate ion, and now that enolate ion is further going to do something. How many moles of aldehyde we have? 2 moles of, and 1 mole of aldehyde we have used in this to form an enolate, which is strong nucleophile. And now our second aldehyde is still there in our reaction. Now this enolate is nucleophile. It is a nucleophile. It is having a lone pair. It's a nucleophile, and now this nucleophile is going to attack on the electrophile. Now tell me that which electrophilic center, which electrophilic site present in this aldehyde, in this carbonyl compound? This carbon. This carbonyl carbon is electrophilic center. This carbon is being more electrophilic because this carbon is attached with oxygen in the pi system, in the pi bond system. Oxygen is high electronegative, it's very high electronegative, and that oxygen is going to pull the electron density towards it. So because of that, this oxygen is having a partial negative charge. Because of its high electronegativity, it will pull electron density towards it, and the carbon is being less, and then the carbon is having less electron density because of it is a less electronegative, so it is a in electron deficient state. This carbon is electrophilic, and this is nucleophile, this is electrophile. So simply this carbon is going to attack on the carbonyl carbon. So this nucleophile is going to attack on this electrophile, and now you know that once there is an attack, the bond is going to form, and now this carbon and this carbon will have a bond, and that is this CH2, this carbon is going to attack on this carbon. So now this carbon and double bond O, and then CH3, and then proton as well, hydrogen as well. And now this carbon is having 5 valency. So to stabilize that, this oxygen will accommodate this oxygen will accommodate this pi bond in the form of electron. This oxygen will accommodate this pi bond in the form of electron, and now there is a formation of oxyanion. Now there is a this kind of intermediate will have. If we don't have alpha hydrogen, if we don't have alpha hydrogen, what is going to happen? There is a no formation of enolate. There is a no formation of enolate. What does it mean? Instead of abstracting the proton, this hydroxide is going to attack on the carbonyl carbon because of it is a nucleophile and again it is electrophile. So to avoid that, we are having an aldehyde or ketone that have alpha hydrogen. If I'm going to choose formaldehyde, if I'm going to choose formaldehyde, then this reaction is not going to favor or not going to have aldol condensation, and because of that, this is our strategy in this to form an enolate, and then further that enolate attacks on that, and we have connection between this carbon and this carbon to make a bigger molecule. And now we are at this point now. Now what we have water as well in this reaction. So now that water H plus and then OH minus. So now this O minus will have that proton and will form OH and will form this OH. So this is aldol. This is aldol. You can see that this is aldehyde and this is alcohol. So this is an aldol. This is an aldol. And now this aldol is further going to loss of water and will end up with our final product. But again, before that, there is a one more concept, and that is even CB reaction. Even CB reaction. It is a type of elimination reaction. Elimination conjugate base reaction. Even conjugate base reaction of aldol leads to formation of our final product, which is alpha beta unsaturated carbonyl compound. We don't have unsaturation right now in this, we just have aldol, but further we need to make it in the form of unsaturated product, and for that we need to remove water, and to perform that we have to perform even CB reaction, and now we'll do that. It is an elimination reaction. Again, the NaOH, the base in our reaction, that base hydroxide is coming again to abstract a one more alpha hydrogen. You can see that this is that same site, this one. First, there were three alpha hydrogens, right now two, and now one more being abstracted by that hydroxide, and now one proton is going with that and will form H2O and that leave. And now again there is a formation of enolate ion. Again there is a formation of enolate ion. and now this enolate ion is our conjugate base, Cb, even Cb, the conjugate base. And I explained you that the more stability of conjugate base makes alpha hydrogens more acidic, and now this conjugate base enolate is having this electron density, and now when that electron density is there, simply this electron density will make double bond between this carbon and this carbon, and then this carbon is being unstable with 5 valency, so this compound will simply kick off that OH, and OH will leave, and when this bond is going to break, that electrons are going with oxygen because of the higher electronegativity, and now this carbon is going to be stable, and we are having our final product, which is alpha beta unsaturated carbonyl compound. You can see that this is our group aldehyde, and this carbon is alpha carbon, this one is beta carbon, and between them there is a formation of unsaturation, alpha beta unsaturated carbonyl compound because of this carbonyl carbon, or we can say alpha beta unsaturated aldehyde. If we choose ketone, then the product will be different. So this is what all about the aldol condensation reaction. Though OH is not living, though OH is not good living group, it has to live because of there is a formation of this enolate conjugate base, and simply it makes that unsaturation over here, and that forces that OH to live, and will end up with our final product. Thank you.